Hello learners, welcome to this course on Embedded System Design using Raspberry Pi 4 module. In this tutorial, I will be describing about how to use interrupt functionality in Raspberry Pi 4, especially the external interrupt. So the complete project and its code is available in the GitHub repository link given below. So an interrupt is a signal generated by a hardware or software when a process or event requires immediate attention. When we connect a peripheral to any controller, the peripheral may request the service of the CPU. So in that case, it will generate an interrupt signal. Upon receiving the interrupt signal, the CPU will execute a program related to that peripheral device. So this peripheral can be an internal peripheral or it can be an external peripheral. So internal peripheral in the sense inside the microcontroller itself we can have some peripherals. So those peripherals need attention. So like timers or counters or UART or I2C protocol, etc. So we can also have external peripheral which can make a request to the CPU for executing a program like ADCs, switch, keypad or keyboard, joystick, mouse, etc. So this interrupt can occur during a rising edge. Rising edge in the sense from logic 0 to 3.3 volt, or it can be during falling edge. Falling edge means 3.3 volt to 0, or we can also use the interrupt functionality when we have both rising edge and falling edge. So what happens when an interrupt occurs? So usually the interrupt is generated by a peripheral device. When an interrupt occurs, what will happen is the program which is executed by the CPU is temporarily stopped. So this is the main program which is being executed by the CPU. So when an interrupt comes, this main program is temporarily stopped. So it is temporarily stopped and the program execution is diverted to the interrupt service routine. So this section is your ISR, interrupt service routine, which will enable the service of your peripheral. Whatever request raised by your peripheral will be serviced by executing this program. So this program is called as an interrupt service routine. So after the completion of your interrupt service routine, the program control will again come back to the main program and it will continue its operation. So this is how the interrupt mechanism is being processed by a microprocessor or a microcontroller. Let me repeat it once again. The CPU, it will execute some program by default, right? So it might be doing some work by default. So for example, this is the section where I have my main program, which the CPU is currently executing. So during the execution of the main program, an interrupt occurs. A peripheral generates an interrupt. At that time, what will happen? First, it will complete the current instruction and then the main program will be temporarily stopped. So after stopping the main program, the program control will go to the ISR. ISR stands for interrupt service routine, where we will execute a program, the CPU will execute a program, so thereby the service required by the peripherals will be satisfied. So after completing the ISR, the program control has to come back again to its main program. So it will be routed to the main program and the CPU will keep on executing the main program. So that is how the interrupt being serviced. So now in this project, what we are going to do is, we are going to connect a switch to GPIO 17th pin. So now this GPIO 17th pin, we are going to use it as an external interrupt pin. External interrupt pin, and we are going to generate an event in this pin by pressing a switch. Whenever we press a switch, what we are going to do is, we are going to blink this LED connected to this GPIO 18. So that is what we are going to do. So here it is not something like a IO programming, right? So here it is an external interrupt. Whenever we press the switch, a interrupt service routine will be executed. In the interrupt service routine, we are going to make this LED to blink connected to GPIO 18. So there are different pins can be used as an external interrupt pin in case of your Raspberry Pi 4. So some of the commonly used pins are GPIO 17, 18, 27, 22, 23 and 24. So for this project, we will be using Proteus 8.13 professional software and the language of programming will be Python. Now let us go into the program. We need to import the necessary packages which we required for our execution. So one such package is your GPIO package, rpi.gpio, because we are going to make use of a GPIO pins for connecting both your LED as well as the external device. Then we require a time package which is used for creating the delays. Then I am going to initialize two variables, button pin and LED pin. So button pin is assigned with 17, LED pin is assigned with 18. Then I am going to do the configuration part. So first initially I am going to set the mode stating that we are going to use the IC pins. So the IC which we use in our Raspberry Pi 4 is BCM2711, which is a ARM Cortex A72 processor. So we are going to make use of the IC pin that we are stating in this statement. Next, we will be using a button pin. So button pin is where we are going to connect the switch. So that pin we are going to configure it as an input pin, and also I am going to enable the pull-up mode. So pull-up mode means by default the pin will be at logic high. Whenever we press the switch, it will go to logic 0. Then I am going to configure the LED pin as output pin, and I am going to make that LED pin to be in logic low. So the LED will be in off state by default. Then we are going to write an interrupt function, interrupt service routine. This is the ISR which I am talking about. So this ISR is defined by this DEF button callback function. So where we are going to write something like interrupt detected on GPIO 17. So inside that ISR, I am going to make this LED pin to go to high. So the LED will switch on for 1 second. After 1 second, it will go to low, which means it will get switched off for 1 second. So this is an ISR. So in order to create this interrupt function, we have to add an event. So GPIO.add_event_detect, where I say the interrupt pin is pin number 17, and I am going to configure this interrupt for falling edge. Falling edge in the sense from 3.3 volt to 0 volt. So whenever the voltage change happens from 3.3 volt to 0 volt, an interrupt will be triggered. So I am going to say when this event happens, I am going to call this interrupt function called as button_callback. And the bounce time, since we are using a switch, there will be a bounce time. So when I press a switch and release the switch, so the oscillations will be there when I press a switch. So in order to eradicate or remove this key bounce, we wait for 500 milliseconds. So until 500 milliseconds, if any transition happens after pressing a switch, it will not be taken into account. So we are adding an event. So when this event occurs, it will go to this ISR and it will execute this program. So we define our main program by saying that running press button connected to GPIO 17, and since our embedded system is going to run continuously, this is the main program. So this is the main program which will be executed by the CPU. In the main program, what happens? The LED is in off state. LED is in off state and it is continuously running in a while loop. So LED will be always be in a off state. Whenever I press a switch, what happens? It goes to this ISR, it enables the LED, and after 1 second it disables it, and again it will come back to the main program. So again in main program, the LED will be in off state. Again when I press the switch, again it will go back to the ISR, it will execute the program and it will come back. So that is how the interrupt is being processed by the Raspberry Pi 4 module. So then we call this main program using this code and we try to compile it and we will try to execute it. Now we will go to the simulation part and we will look at the execution. So here I show a typical circuit diagram where we have connected the switch to GPIO 17th pin. So this pin will act like a external interrupt pin. And we have connected the LED to GPIO 18. We will look at the code. So the program which I have just explained is given here. Importing the necessary packages, defining the variables for button pin and LED pin, setting the pin configuration, button pin as input pin and LED pin as output pin. Then we are defining a interrupt service routine program where we will make the LED to be on for 1 second and it will go to off for 1 second. So it will happen only one time. Whenever an interrupt is being generated, this interrupt service routine will execute it for only one time. Then we are creating an interrupt event, and then in a main program we are switching off the LEDs. So the CPU will keep on executing this main program. Then whenever an interrupt occurs, it goes to this ISR, it executes this ISR, and again it will come back to the main program. So we call this main program in this section. So once the code is written, we will try to compile it. After compiling, we will go to the schematic and we will check the output. We will run the simulation. So right now the CPU is executing, so the LED is in off state. So as soon as I press a switch, you can see the LED blinks for 1 second and goes to off. Then it is again waiting for an interrupt. So it is waiting for an interrupt. Right now it is in main program, so LED is in off state. Again when I press a switch, it goes to ISR, it makes the LED to glow one time and it will go to off. So this is how the external interrupt is being used in our Raspberry Pi 4 module. So in this tutorial, I have described about how to create an external interrupt in Raspberry Pi 4 module with LED as an output. Thanks for watching. Please like and subscribe for more technical learning. The complete code and the simulation of the project is available in this GitHub repository link. You can download and you can make use of it. Thank you.